Hello, my name is Todd Miranda, and in this video I'm going to demonstrate how to create dependency properties for your classes in WPF. So let's begin in Visual Studio 2008. You can equally use Visual Studio 2005 as long as you have the right Windows SDK to develop WPF Windows applications. So let's create a new project, and we're going to choose .NET Framework 3.0, so we're not going to use any of the new 3.5 stuff. And the only reason I'm doing that is because I want to demonstrate that you don't have to use any of the new 3.5 stuff for creating dependency properties. And we're going to create a WPF custom control library, just because what we're really doing is we're creating a class that might be a control that you would create for use in another WPF application. So we're not really developing a full WPF application. Alright, and let's name this appropriately. Okay, so in order to demonstrate the dependency properties, let's create a control. Let's say that in WPF you've got the expander control, which allows you to expand and collapse a particular region. Well, let's say that we wanted to develop an accordion custom control. And in the accordion custom control we would have multiple expander controls. But what you'd want to do is you'd want to be able to pin a particular expander control open, so that as you clicked on one and the rest of them collapsed, if one of them was pinned, it would stay open as well. So we're going to create a pinnable expander. So let's get rid of the default custom control, and we'll just create a class. So we'll do project, add class, and we're just going to create a class. We'll call this pinnable expander. Okay, so we need system.windows and system.windows.controls maybe. We may need more, but I think that'll be enough. Okay, so here we've got our class pinnable expander, and we're going to inherit from the existing expander class, because what we really want to do is we just want to use the expander, and we want to add on a property to this expander called isPinnable, or isPinned maybe we'll call it. So one of the pluses behind dependency properties is the fact that the dependency property system in WPF really facilitates a lot of the cool features that are in WPF. So we get on top of just the typical, property functionality that you're going to get with it being a property, you get change notification, you get property value inheritance. Obviously, because it's a dependency property, kind of the definition of a dependency property is that the value of the dependency property depends on multiple providers that will actually provide that value. So that's kind of the dependency, but that's one of the benefits you get, is that multiple providers can add or provide the value for this. So for instance, you could hook up a dependency property to an animation and have that animation affect the value of that property over time. And in order to do that, you'd have to be using a dependency property for that. So now that we know why a dependency property is important and why we want to use it, let's look at how we implement it. And one other thing to note about dependency properties is keep in mind that dependency properties are much more efficient from a storage standpoint. They use a very efficient storage mechanism to handle the storage of dependency properties, which we won't get into the details of that, but just remember that if you've got a class that has a large number of properties, say for instance the WPF button has 96 public properties, all right, I think 71 of those are dependency properties, because if you had 96 instance properties in that button, you may have 10 or more buttons on a form, depending on what your form is doing. That's a lot of memory that's being eaten up with those 96 properties per button. So that's a lot. With dependency properties, there's a much more efficient storage mechanism. So a lot of benefits to using them. So again, let's take a look at how we would implement them. So the first thing that we need to do is we're going to call our property that we're going to create, our dependency property. Let's call it isPinned, and this will be a Boolean property that would be set that would indicate whether our expander is currently pinned or not. So the first thing that we need to do is we need to register our dependency property. Actually, I guess the first thing that we should do to be proper is we'll create our default constructor, and we don't really want to do anything in there right now, but you might want to do some things in your constructor. More than likely, what you'd want to do is you'd want to override the onInitialized event and do your initialization there. So now we want to register our dependency property, and the things that you want to remember are our dependency property needs to be public and it needs to be static. So we'll start with public, static. We're going to register this as a dependency property. Okay, now by convention, if our property name is, or if the property name as we know it is pinned, then our dependency property name is pinned property, and that's kind of the way that we do things as far as just a convention for naming your dependency properties. I would stick with that. That way, if someone's using your control and they want to set the value or get the value using the get value and set value methods, which we'll look at, it'll make sense to them that they'll use the isPinned property because that's just the convention. Okay, so this equals dependency property.register. Okay, and now we're going to take a look at the parameters for our register. The first parameter to our register method is the name of the property, and this is the name of the property as the user knows it. So this is pinned. All right. So the next parameter that we've got in our register command is the type of the property. So this is obviously going to be type of bool in our case, because we want this to be a Boolean property. The next parameter is the type of the owner of that property, and we know that the owner of that property is going to be the pinnable expander. Now it may seem odd, why would we use the owner here? Because this dependency property is being registered within the class. Remember, it's static, so we have to tell it what type our owner is. So this will be type of pinnable expander. Okay, so there's our name, what type it is, and the type of its parent, of its container class, the class that it belongs to. Now for the last part of the register statement, and oftentimes this last part can seem a little intimidating, but it's really not. Effectively, the last parameter that we've got here, it's identified as property metadata, and this allows us to pass metadata into our property. And because of the capabilities of the dependency property, because of the things like change notification and things like if you're working with a visual control and doing something with a property, when that property changes, it might cause the screen to have to re-render, or it might have to cause just that control to re-render. There's all kinds of properties that we can pass in here to facilitate that, so that we don't have to really write any code to handle it. The dependency property system will handle that. So this calls for a new property metadata object, and property metadata has a number of overloads. So we'll start with the first value that we're going to pass in is the default value of our property. So the default value of our property is going to be false. Alright, so the next thing that we pass in here is a property changed callback method. Alright, so when the property is changed, this method will be called from the dependency property system. So we're going to do pinnable expander dot, and we're going to say is pinned property changed. All right, and we haven't written that method yet, but we will. All right, so now the next thing that we can pass into this is a coerce value callback. So what does this do? When the value is being set, you can actually apply rules when that value is being set, and due to those rules, you may want to force that value to something. So you may want to actually override or coerce the value that's being set to the value that you want based on some series of events or rules. And we probably won't really use this. We may, but let's go ahead and put one in here. So pinnable expander dot is pinned coerce. Okay. All right, and that's pretty much it for our property metadata. And there is our register command complete. All right, I'd like to take this a little step further, because in some cases, if you've got a type of control that responds and is some kind of a visual control, you may want to use UI property metadata, which effectively is an override of property metadata, and it allows you to pass one extra value, and that extra value is animation prohibited. So maybe you've got, I said before that since this is a dependency property, an animation could be used to manipulate the value of that property. Well, there may be properties that you don't want an animation to be able to manipulate. So if you set this to true and prohibit animation from being able to affect this, then if the animation does try to affect it, an exception is thrown. Well, this value is a Boolean, and it's is pinnable. I don't really know that we would want to animate the value of this. Now, that doesn't necessarily mean that animation has to be a linear animation. We could do an animation that switched just from one value to another. But just for grins, since we're doing this as an example, let's go ahead and prohibit animations from being able to set the value of this property. Okay, well, let's take it even a step further. Instead of UI property metadata, maybe we want to use framework property metadata, which is effectively an override for property metadata through the UI property metadata, and it gives us another value that we can pass here, and it's some framework property metadata options. All right, so here what we would do is we would say framework property metadata options dot, and let's look at some of the options that we've got. Effects arrange, effects measure, effects render, binds two-way by default. All right, not bindable. Right, so these are additional flags that we can set on our dependency property to facilitate certain things in the framework. For instance, if we set effects measure, all right, which in this case it really doesn't affect the arrange or measure methods, but if we did effects arrange, then when that property is changed, the system would automatically know that it could potentially affect the arrangement of the controls. So it does whatever it needs to do to check and make sure that setting that property didn't change the arrangement of the controls. All right, so we're just going to we don't really need some of those extra parameters in there. We don't really need those property metadata option flags, so we'll just go back to our UI property metadata. But I wanted to show you that there is another type of property metadata that's used commonly. Okay, so where are we? We've registered now our dependency property. Well, now in order to set and get a dependency property, you don't use your set and get commands like we used to with a property wrapper, however, or a property accessor method. However, because you use get value and set value to get and set, respectively, the value of the dependency property, it's also harder to set that in XAML. So what we typically do when we create a dependency property is we provide a get and set accessor method so that it's a little bit more it's a little bit easier for us as developers to use. We're more familiar with the layout and how to use that property, and we can set it in XAML. There's one caveat about using this accessor method wrapper, but we'll talk about that in just a moment. Alright, so let's create here a public bool, and this should look very familiar. It is pinned. We'll create a get, and we'll create a set, and our get is going to return, and a lot of times here you have a private variable. That kind of defeats the purpose, so we're going to do get value, and the dependency property we want to return is pinned property. Remember, because this is the name of the dependency property. And set, likewise, will call set value, and this is going to set the dependency property, which is pinned property, and we're going to set it to the value. Okay, so there's our wrapper, effectively our typical property wrapper around our dependency property set and get. One caveat here: this is good at design time. At runtime, this is ignored, and effectively these are called directly. What that means is sometimes we might come in here, and when the property is set, we might do some custom logic of some sort. Alright, don't do custom logic in the set part of the accessor, and that's because at runtime this is ignored, and when you set is pinned, these guys are called directly, and they don't really go through the set and the get accessor methods or the parameters. So your custom logic here will not be run. Instead, implement your custom logic in the changed event handler that we set here. Our isPinned property changed. Do your custom logic there. So when the value is set, that will be called, and you can do your custom logic. Alright, so I guess the next thing to do then would be to do our isPinnable property changed. So let's see what we called that. IsPinned property changed. Let's come down here and let's do a private static void. There's our method name. Alright, so this takes a dependency object and a dependency property changed event args. Alright, so here is where you would implement any of your custom logic here in the changed event. Alright, so as an example, let's say that if the isPinned flag is set and the expander was expanded, let's why don't we, or if it's not expanded, let's expand it. So let's do here we're going to say pinnable expander inst equals pinnable expander d. So we're going to cast the dependency object coming in as a pinnable expander, and then we'll just say something like this. We'll say if bool e.new value equals, so we're going to set if the new value is false, so we're unpinning this pinnable expander, then we'll do inst.isExpanded equals false. So if we unpin it, we're going to collapse it. Okay, so that's an example of something that we could do in our property changed event. Alright, so the last thing we need to do is we need to do our course event. So we come over here, we'll grab our isPinned course, and we'll come right down here, and we'll actually copy this, and this is going to be is pinned course. It takes the same dependency object, except it takes here just an object value. Okay, so here in our coerce, since we're not necessarily going to coerce the value back any, what we'll do is we'll just simply say return value. And this needs to be object because we'll be returning an object. Okay. And this is a value in the course is the value that's actually it's trying to set it to. So let's build this. See if we've missed anything. Ah, yes. Since we created our solution as a custom control, it created a default theme. We're just going to remove that default theme from that custom one. Build, we should get a good build. Build succeeded. And now you can use your pinnable expander in your control, and it's got an isPinnable property, which is a dependency property, and can be used in binding operations. And that's pretty much all there is to it to creating dependency properties for WPF classes.